I'm saying at any time t seconds, like t could be 1 2 3, any, like, it could be any number, but we are not taking a number right now. Okay, to be very clear over here, don't be obsessed with the formula. Please do understand the concept, because in the final paper it's not compulsory that they give you like projectile motion as it is right now over here. The projectile may start from half of, like, you might there must be something dropping with some horizontal velocity only, like something of the half of the projectile and all, but the concept that I'm using over here would be same. So if you know the concept, you would literally be able to do any question asked on projectile motion. Okay, so please look at the things now carefully, how we are using information of y-axis and applying them, what information I can apply in the x-axis and all. Okay, cool. So here we are finding out what is the velocity in y-axis after a time, like at after a time t seconds. Okay, not at, after a time t seconds. So t is t seconds, time is given t seconds. Okay, initial velocity in the y I know is u sine theta. Okay, so I want to find out vy, so I can simply use, I know the acceleration is equal to g, so I can simply use first equation of motion, which is v equals u plus at. So if I use it, I get the final velocity in y as initial velocity is u sine theta. Instead I'm going to write minus g, so minus gt. So this is the expression. Now if I put t equal to 1, I will get the velocity after 1 second. If I put t equal to 2, I will get velocity after 2 seconds. Okay, so I hope it is clear. Okay, cool. Now the next task is, we want to find out what will be the maximum height reached by the projectile. Okay, like it's like if you kick a football. Okay, like you kick the football, and what is the maximum height the football will go to. So this is what, let us say, if we want to find out that again, so you need to know that this is the information of y-axis. So basically I'm finding out displacement in y-axis, right? So I would use the information of y-axis only. So the same thing, the same football, you're kicking it at with a velocity u at an angle theta, x-axis velocity is u cos theta, y-axis velocity is u sine theta, and this maximum height is also in the y-axis. So I know that the initial velocity in the y-axis is u sine theta. Okay, and as we have just discussed that the at maximum height the final velocity will become 0, right? So I know the final velocity is 0. What else I know? Do I know what time it reaches to maximum height? No, we don't know that, but we do know the acceleration is equal to g, right? So now which equation of motion shall I use to find out displacement? But we don't have time, so we can use the third one, right, which says v square equals u square plus 2as, right? So if I put the values, v is 0, 0 square, u square, instead I'm going to put u sine theta, so u sine theta whole square, minus 2g, instead s I will write h max, the maximum height, because I'm using the conditions for maximum height. That's how I'm putting v0. So if I use algebra and send this u sine theta this side, so I'll get u square sine square theta equals negative 2gh max. I can cancel out this negative signs, and then if I write it over here, so I get v square sine square theta equal to 2gh max. So from here, if I make h max the subject, so h max, the maximum displacement reached by the projectile, comes out to be nothing but v square sine square theta over 2g. So if you know theta, if you know v, you can know what is the maximum height reached by the projectile. Okay, cool. Now if you want to know what will, like, after what time it will reach to the maximum height, let us say time taken, time taken to reach the maximum height. So in other words, I can say time taken for half the projectile from here to here. If we want to know that, how will we do it again now? Okay, let me take the same thing, same football. This velocity is u sine theta, this velocity is u cos theta. Okay, now our task is, this is maximum height. My task now is, how long will it take to reach to the maximum height? Okay, so now again I will use the information of y-axis, right? So I have the initial velocity as u sine theta. I know the acceleration is equal to g, right? And the next thing I know is that the velocity is becoming 0, right? And we know displacement as h max. So here I have two options. I either can use v equals u plus at, because I want to find out t, or else I can use s equals ut plus half at square as well, because I know s2. right? I know displacement as well, but I will not go ahead with this because this will give me a quadratic equation. When I have a linear equation, why would I choose a quadratic equation? Never. My task is to make my life easier, not harder. Okay, so I'm not going to use it. So we'll be using the first equation of motion. So if I use this, I know final velocity is 0, initial velocity is u sine theta, okay, and acceleration is g, okay, time is t. So from here, if I make t the subject, I get gt equals u sine theta, right? So from here, if I make t the subject, I get time nothing but u sine theta over g. So this is the time taken for the ball to reach to the maximum height, means from here to here. Okay, now what if I want to find out the total time taken? What if I want to find out that if I kick the football, after how many seconds it will reach to the ground again, means the entire time. Okay, so let me tell you, it's very simple over here. If I already know how much time it takes to go up, okay, I've just calculated the time it takes to go up is u sine theta over g, right? So it will take the same time to come down. Whatever time it has taken to go up, the ball will take the same time to go down. So it will take u sine theta over g to go down also. So what will be the total time of the flight? Total time of the flight is going to be nothing but u sine theta over g plus u sine theta over g. So the total time of the flight would be nothing but 2u sine theta over g. Okay, that means when you kick the football will remain in the air for 2u sine theta over g time. Okay, cool. Now comes something very important. So far, if you have seen that I already separated the y velocity with the x velocity, right? This was u cos theta and the y velocity was u sine theta. I separated them and I showed that how the y velocity was kept on changing, but the x velocity remained constant, right? So you might be thinking, then what is the similarity between them? What's the one thing that is combining them? Like what is common between x-axis and y-axis? So now this step is really important in projectile. So if you see, the only common thing between x-axis and y-axis is the time. Okay, so any projectile, like if it is, moving up and down, if it is taking 3 seconds to move, like if it is taking 3 seconds in the air, that means in these 3 seconds the projectile is moving up, like it is having displacement in y as well as in x. So the only thing which is common between the y-axis and x-axis in projectile motion is time. Okay, so in the previous part of the video, we have already found out the total time of the flight was 2u sine theta over g. That means in 2u sine theta over g time, this ball, if I only look at the y-axis, this ball moves up, becomes at reaches at 0 velocity and comes down and hits the floor. If I only look at the y-axis, and then if I look at the x-axis, in the same time 2u sine theta over g, the ball covers this distance in the x-axis, and this distance is called range. Okay, so let me explain you again. So what is range basically? So the range is the distance traveled by an object in the projectile motion in the x-axis. Means what is its displacement from its initial position, which is a, to its final position, which is b. Means how far it lands on the ground after you have kicked it. Okay, so this distance. So now how do I find out this distance? Quite simple. I already know the velocity in the x-axis, which we discussed as u cos theta, right? And I know the time taken to reach from here to here is the total time of the flight, which is 2u sine theta over g, right? So once I know all this, what do I need? I need distance, right? Now I can simply use speed equals distance over time. So hence distance is speed into time over here, because I know the motion is not accelerated. The object is moving with a constant velocity in the x-axis. So I already know the speed is u cos theta, right? And the total time taken is 2u sine theta over g. So this is how I can know the range, like what will be the displacement in the y-axis. The formula comes out to be u cos theta times 2u sine theta over g. Okay, so again I'm telling you, don't be obsessed with the formula. Okay, the concept is this. So somewhere if they want you to find out the range in the x-axis, what you will do is you will find out the total time taken using the information of y-axis. Okay, time, you will find out time taken using the information in the y-axis. Find out time taken. Okay, if it is given, if the y information is given, use the same time for the x-axis, because the time is only one thing which is common between x and y. So if you know this much, all these factors, you are in a very good condition now to solve past paper questions. So in the next video, we'll be solving questions on projectile motion, and I'll show you different types of questions that can be asked. Okay, till then, keep revising. Bye bye.